Hello everyone. Today I'm going to discuss the 4-bit synchronous counter. So once again welcome back to my channel. Here I'm making this video for 3 mark question because this question is very important. You may expect this question for 3 marks, that is in part B of diploma subject digital electronics. So let me clear all of you that first how to remember the circuit diagram in an easy way. So since the heading is 4-bit synchronous counter, therefore we have to use 4 flip-flops here, and here make sure that we have to give the inputs as JK inputs only, because all the counters they are designed by using JK flip-flop. So this is the first flip-flop, second, third and fourth flip-flop. Here make sure that we are discussing about synchronous counter, not asynchronous counter. In the earlier video, in the last video I have discussed 4-bit asynchronous counter. The difference is in synchronous counter we apply the clock pulse simultaneously. So you can see here this CLK means clock signal. So we are applying the clock signal simultaneously to all these flip-flops here. And that to which type of triggering means is a negative edge triggering. So how to differentiate between positive edge and negative edge means. So here we are keeping a bubble before this edge, therefore it is a negative edge triggering flip-flop. So here we are using a negative triggering clock pulse. So look at here, and one more difference between the synchronous and asynchronous counter with the help of diagram is for the first flip-flop only we are making we are giving the connection to the plus 5 volts, nothing but logic 1 input. That means always the first flip-flop will be in the toggle mode. Always the first flip-flop will be in the toggle mode because we are directly connecting the J and K input to the plus 5 volts, that is logic high. But coming to the second flip-flop, look at here how the connection is applied. The output of the first one is directly connected to the J1 input, and similarly this connection is also applied to the K1 input. Okay, unlike the previous one where in asynchronous counter all the inputs J0, K0, J1, K1, J2, K2, J3, K3 they are connected to plus 5 volts directly. But here, so do remember we are giving the connection only to the first flip-flop, whereas the second one, here for the second one we are connecting from the output of the first one. Look at here, Q0 is connected as input to J1, and similarly this connection is also applied to K1. Okay, and here we are getting the output Q1, and the next complemented output is Q1 bar. So this Q1 output is connected to AND gate. Here we are using a combinational logic circuit, that is AND gate. So one of the input to this AND gate is Q1, and the other input we have connected from this Q0. So this input is what? Q0. That means the inputs for the AND gate are one is Q1, second is Q0. Now the output of this AND gate is connected as input to the third flip-flop, that is J2 and K2. So look at here, this in output is connected to J2 and the same output is also connected to K2. Okay, and similarly the Q2 output is connected to another AND gate here, and another input for this AND gate is given connection from output of this first AND gate. So take it as a first AND gate and take it as a second AND gate. Okay, so what is output of this AND gate? One input is Q1 and the other input is Q0. So here we get the output is a Q1 Q0, and similarly here this Q1 Q0 act as input to this, means here the output will be what? It is Q2 Q1 Q0, because we know that AND gate performs multiplication of the inputs. And finally we get the output Q3 and a Q3 bar. So this is the diagram. Do remember how to draw it in easy. First we have to draw the 4 boxes, nothing but indicating 4 JK flip-flops. Then give the connection, that is plus 5 volts connection only to the first input J0 and K0, and give the clock connection to all these flip-flops because it is a synchronous counter. Make sure in exam which counter is asking, is it asynchronous or synchronous. If it is synchronous you have to give clock connection simultaneously to all the flip-flops, and if the output of the first one act as input to this J1 and K1, and next Q1 output is given as one of the input to the AND gate, and the other input is connected directly from this Q0 output of the first flip-flop, and the output of this AND gate is connected as input to J2 and K2. Here we get the output of AND gate is Q1 Q0. Similarly the second one, the third one output is what? Q2 is connected to this AND gate, and one more connection is given from this. So this is a diagram. So do remember and try to draw in the similar way. And next topic we have 4-bit synchronous up or down counter. 4-bit synchronous up or down counter. That means it is a single counter which is performing dual role. That is, it behaves like a up counting as well as down counting. So let me discuss first what is the definition of up or down counter. So there is a probability of asking this question for 1 mark. Define up or down counter. So up or down counter means a counter which can count in both the directions. A counter which can count in both the directions is called as up or down counter. Up counting means counting in the ascending manner. Down counting means counting in the descending manner. That is from 0, 1, 2, 3. Increasing order is nothing but up counter, and decreasing order is nothing but down counter. So do remember, whenever a single circuit is behaving like a dual role, whenever it is functioning like a dual role, then in that case we have to use a control input. In that case we have to use a control input. So similar diagram, that is similar circuit which performs a dual role, we have discussed in 2's complement adder or subtractor. If you have remembered your second unit, in that we have discussed 2's complement adder subtractor, where single circuit can behave like adder as well as subtractor. So similarly here also, since it is also a 4-bit. So one more thing, so if in exam if you ask about only 3-bit, then you have to draw only 3 flip-flops. Okay, because each flip-flop can store 1 bit of information. So like that you have to remember, for 3-bit you have to use 3 flip-flops, for 4-bit you have to use 4 flip-flops. Okay, and all these are JK flip-flops only. So see here the same diagram. Here we are using again JK flip-flop, J0, K0 input, J1, K1, J2, K2 and J3, K3. So J0, K0, it is connected to plus 5 volts. It is connected to plus 5 volts. The first input is connected to plus 5 volts logic high. And similarly from this plus 5 volts we have given connection to J1, K1. And this plus 5 volt is also connected to J2, K2 and is also connected to J3, K3. So it is what 4-bit, it's not synchronous, it is asynchronous. The heading is 4-bit asynchronous up or down counter, and the clock input is applied only to the first flip-flop. And we know that since it is asynchronous, the output of the previous one acts as input to this clock input to the remaining flip-flop. So for that, here we have to use since it is behaving like two roles, therefore we have to use a control input up or down. Here up or down nothing but it is a control input. It is a control input. Next, here from this output Q0 we have to connect a AND gate. So one of the input for this AND gate is connected from Q0 and other input is connected from this upline. So all this top line indicates upline, and here this bottom line from where we have connected to a NOT gate, it indicates downline. It indicates downline. So this up counter connection is given to the uppermost AND gate, that is the first AND gate, and from Q0 bar we have given connection to second AND gate, and the other input to this AND gate we have given from down bar. And the output of these two AND gates are connected to a OR gate. Now the output of OR gate actually act as clock input to your second flip-flop. And here we are using a negative edge triggering flip-flop. So look at this bubble connection here. And similarly here also the output of the Q1 is connected to AND gate. Okay, and other input is given connection from upline. Similarly Q1 bar is connected to fourth AND gate, and another input for this fourth gate is given from downline. And the output of these AND gates given to the inputs of OR gates, and finally this OR gate output behaves like clock input to this third flip-flop. And similarly in the similar manner the last one is also like that only. We are using AND gate. So one of the input for this AND gate is upline, and for the downwards AND gate another input is given to the down bar line. And finally the output of OR gate act as clock input. This is a circuit diagram. I hope it's easy to remember. So in up or down counter, do remember we have to use what a control input whose name is what up or down. So we have to use the in between of the flip-flops we have to use AND gates, two AND gates, and the output of these AND gates connected to OR gate, and one of the input to this AND gate is given from the upline, and here it is given from the downline. Okay, so I will tell you the detailed description or the detailed functionality of up or down counter in my next video, because if I continue in this video it becomes too lengthy and you get bored. Okay, but as for now just do remember the circuit diagram. Okay, if it is a 3-bit in examination, if it is asked for 3-bit, then you have to draw only 3 flip-flops. Okay, so the next topic is the last topic, and next topic is 4-bit ring counter. It's a 4-bit ring counter. So here the name itself indicates ring counter means it has to behave like in a ring manner. The output of the first one act as input to second one, second output act as input to third one, and third one act as input to fourth one. Finally the last output is connected back to the first one. So in the similar manner 4-bit ring counter means. And one more thing here, for ring counter designing we don't use JK flip-flop, instead we use D flip-flops. That's why ring counter is also known as shift register. Ring counter is also known as 4 bit. It behaves like a shift register. So look at here. So here we have used D flip flop. The first flip flop D naught output is Q naught. This output connected as input to D1. Q1 is the output connected as input to D2. Q3 is the output connected as input to D3. And the last output is connected back to the first one, that is D naught. That's how it makes the difference. Okay. So this additional connection make it as a ring counter. Apart from that, here we are giving the clock input simultaneously to all these flip-flops, so you can consider it as a synchronous counter only. And the one thing which differs this ring counter is we have to apply a preset input only to the first flip-flop. Preset input only to the first flip-flop. I have already told in the previous discussion, preset input is considered as asynchronous inputs. In exam, there is a chance of asking what are the asynchronous input for 1 mark. So there are two types of asynchronous inputs. One is preset input, other is clear input. One is preset, other is clear. The meaning of preset is it automatically sets the output of the first flip-flop to 1. It automatically sets the output of the first flip-flop to 1. Whereas the output of the remaining flip-flop will be 0. Output of the remaining flip-flop will be 0. So at the end of the so before applying any clock pulse, the overall output of this flip-flop will be 1 0 0 0. Okay, so why this one occurred? Because of this preset input. Okay, so do remember this diagram. It will be asked for 3 mark. Draw the diagram of 4-bit ring counter. So here it includes the operation of this. So the operation of this counter can be explained by using a truth table. Here we have the clock pulse. These are the outputs we have: Q0, Q1, Q2, Q3. So here we are not, before applying any clock pulse, so the output of the Q0 is set to 1. Okay, the output of this Q0 is set to 1. This one occurred because of preset input, which is the asynchronous input, and the remaining outputs will be 0 0 0. When the first clock pulse is applied, then what happens? So this 0 is then this output act as input to the first one. So this 0 appears and it gives the output of the Q0 as 0. And what about this one? This one is transferred to Q1, shifted to Q1. That's why it is also called as shift register. So this one is shifted here, this 0 is shifted to the next flip-flop, and this 0 is shifted to the next flip-flop. So simply I have drawn like this. Why? Because D flip-flop, in D flip-flop is the only flip-flop in which output is equals to input. In D flip-flop, output is equals to input. Whatever the input we give, the same output we get. So that's why what is the D naught value we have, the same we get as Q naught. D1 is equals to Q1, D2 equals to Q2, D3 equals to Q3. Okay, when the next clock pulse is applied, the second clock pulse is applied, this 0 is shifted to the next flip-flop, therefore Q1 becomes 0. This one shifted to the next one, this one 0 shifted to the next one, and this 0 occupies to the first flip-flop like this. That's why I have drawn this circle manner. Okay, when the third clock pulse is applied, this 0 comes here, this 0 comes, and this one is shifted here, and this 0 occupies the first flip-flop. When the fourth clock pulse is applied, this 0 shifted to the next one, this 0 shifted to say third flip-flop, this 0 shifted to this one, and this one comes to the first flip. Now look at here. This 1000 is the actual data which we have started. Okay, so this is the one we have reached. Okay, 1000 is the data from which we have started. Okay, so if we count the total number of clock pulses, how many clock pulses it has taken? 1, 2, 3, 4. Total it has taken 4 clock pulses to count a 4-bit data or to shift 4-bit data. So to count n number of bits, it takes how many clock pulses? N number of clock pulses. So this kind of questions you can expect in your ESET. So in future also I'm going to make the videos related to ESET from counters, next combinational circuits, not only from counters and combination but entire digital electronic circuit. It will be useful for your competitive exams and as well as for ESET exam. And those who are going to the technical background like hardware engineering, then definitely digital electronics is going to the fundamental subject. You must be aware of each and everything. For that, in order to get updated knowledge about data electronics, please like, share and subscribe my channel. Thank you.